All right. Today is July 1, 2026. This is a meeting of the Container Storage Interface community. We're doing a one-off meeting to discuss a couple of topics that have been pending. We did skip the last meeting, and this topic is urgent, so we wanted to hold a meeting to discuss this one. Um, the first topic is CSI volume health. Hamad, looks like you left some questions and comments here. Do you want to get started with the intro?
Yeah, sorry. So, CSI volume health, as you know, like we have been working on this for a while now, and the current proposal is is alpha, and it was represented using volume condition APIs, like as part of basically Node get volume stats. Those APIs where the health was embedded into list volume and Node get volume stats. So each time user fetches list the volumes or user checks for disk users and things, they get volume health. As part of this new cap, like this new CSS spec change, we are uh, taking that apart from volume condition and making it a standalone RPC calls hidden behind its own capability. So, uh, I think the the APIs are like out there for review. So the what we are proposing is there are we are proposing four new RPC calls. I think one is for controller get volume health. That is to get list of get a health of one individual volume. Then we are proposing controller list volume health, which allows users control plane to list like all the volumes that it knows about of all the volumes. Then on the node side, we are proposing node get volume health, which is similar to controller get volume health, except like getting the health of the volume from the node. And uh, and then there's a new RPC call that and completely new idea basically is node get storage health. And the idea behind that is like to get health of the storage system subsystem from the CSI driver's perspective on the nodes. For example, like NFS server is unreachable from the node or one or more multipath are inaccessible from the node. So those issues will be more observed from the node. And so we are so that this node purpose of node get storage health is not to get health of one volume, but get health of overall storage system from the node perspective. So these are the four RPC calls we are proposing. And like it's like again, so the one of the key thing that we had like during it was a lot of discussion was captured in Google Doc. Now going back to the controller get volume and controller a node get volume RPC call. If you see the API, the each of those types have. Sad, if I can I share my screen?
Yeah, absolutely. Let me
We got
see.
to make you a co-host, right?
Yeah, hang on. I'll make him a co-host.
But while you're doing that, I just want to say that like I support this high level approach. I think it's the right way to do this. I have some questions about specific implementations, but we'll get to
Sure,
those.
sure, sure, sure. Yeah. Let me just okay. Okay. Can I share the Firefox window? Okay, you should be able to see my Firefox window, I think.
Yeah,
And that just
it's in
shows the
portrait mode, so it's kind of zoomed out.
it's portrait mode.
It's very vertical. If you could like shrink it vertically, it'd be easier to read.
Okay. It's still
Oh, there, that's better.
but I will just increase the font size. Good, better?
Yeah, yeah, it's fine.
Okay.
It's fine.
Yeah. Okay, so the the primary use case what we're talking about, if you go to CSI spec.md file, and these are the RPC calls that being introduced. Now the main thing that where we had like some debate and is like how does the health response looks like, and what we have narrowed down is like a list of volume health. So the each for a single volume health basically this is controller list, but it applies to controller get volume health. It's also, so just let's look at the controller get volume health because that's the meat of the idea. So controller get volume health request looks like this ID and it has a secret. Controller get volume health response has just one message, controller volume health, and volume health is has this is of type. It has it has a volume health entry, which could be, it has a volume ID that is be and expect for individual volume health, and it has a repeated volume health entries. So, and volume health entry is has a status, reason, and message. So basically, a single volume can reports an array of health conditions. So not just one, but more than one.
And
So
healthy is denoted by an empty array.
correct. Health is denoted by an empty array. And so the volume health error type is the one that we actually pretty much predefine these the three health error types: inaccessible, data loss, and degraded. So, and we have added specifically wording here that the that new volume health error types can be added in future. So the CO must tolerate that. There is wording there somewhere in the spec. Then we
So
have,
this is the first place where I wanted to recommend a change. I think we had agreed on a fairly specific definition for inaccessible and data loss, but degraded was meant to be more of like a wild card catch-all kind of a status, right?
right.
So I would want degraded to be the first one in the list because we anticipate adding more specific ones, and ones that used to be degraded might become those more specific ones. But we wanted to have just a non-specific one because every vendor has something weird that can happen that's not well captured by a CSI enum type.
Okay. I
So the wild card
think,
should be the first one, assuming we're only
okay.
ever going to have one wild card.
Okay. I seems fine. I do not see
Just from
any.
an expandability point of view, right? Like when we
Okay.
add the fourth one and the fifth one, we're going to be added at the bottom.
Yeah. And then we have, I think that is okay. There's a wording here actually, like this is the one that says about the repeated volume health and the health status associated with the volume. An empty list, no adverse health known by plugin. The SP report one or more health status is with the volume at the same time. A future version of CSI spec may introduce additional volume uh, uh, error types. A plugin that adopts newer spec version may report newer error types alongside the existing ones, but must not remove an older error type entry from health statuses until that condition is no longer present. CS may ignore unknown volume health that they don't know about. So I've given here example CSS spec 1.2012.3 has like reports some adverse as degraded, and 122.5 adds a new here like error type called multipath loss. Then the plugin upgrades and it reports degraded and multipath loss for this volume. An older CO that does not recognize multipath loss still acts on degraded as before and surfaces the unknown value of for observability without taking automated actions on it. So,
I agree with the principle of that. I think we want to re-wordsmith that, but yes,
okay.
yeah.
So
Hey, sorry.
that is the
Sorry, going back to the earlier comment that Ben made, so you're saying what's that, the degrade, okay,
degraded
remove
one.
this one
Yeah.
to one, right? And then what about the inaccessible and the data loss? Is inaccessible the worst? You don't have access to, there's not, of course, data
It,
is also
it,
lost. Or is it?
it's not that like one is worse than the other. It's that like we
Mhm.
have there's specific remediations that are recommended for inaccessible and data loss that we will implement on the CO side in response to inaccessible and data loss.
Yeah. We
Okay.
But
had
degraded, we will not implement any automated response to. It's sort of just like an informational something's wrong, but nothing's going to happen in response to that thing going wrong.
Okay.
We are not like this. This was brought Zing added this comment
Right.
in the
Mhm.
we are not defining a priority of errors at this
Mhm.
point. Like at least in the like okay, the one is more of more severity or more severity. One is more severe than the other. We're not defining that. How they interpret it is interpreted by the CO is like yeah.
Right, like for example, if you get this get one type of error from the controller side, the other a different one from the node side, like which one do
So
you
that is
think
not a
is better?
issue, and I think I have tried to address that in the cap actually that
Mm-hmm.
like each type of error code is actually acted by like a different controller or operator, whoever acts on it. Like inaccessible prevents scheduling to like so if the controller reports volume is inaccessible, it prevents scheduling. If the node reports inaccessible in node get volume health, it prevents scheduling to that particular node. It's and so that decision doesn't picture into whether the other error is what is data loss is doing. The data loss is like, for example, if like another operator which decides, which looks at PVC that is using this volume report data loss, it wants to build another replica, delete the PVC and build the replica. That is that is like kind of orthogonal to what inaccessible is doing to the decision, if that makes sense. Like
Yeah,
Mm-hmm.
so each remediation is basically looking at one health status. So what the inaccessibility controller is looking for all the inaccessible volumes. The data loss controller is looking for all the data loss volumes and only acting on those.
yeah, I do not see that as a conflict. Like yes, so I think it should be okay.
Yeah, I think this is mainly about if you get the different signal from the controller side, node side regarding the same volume, what do you do? Or is it okay, we just say, they just handle it differently, they don't really cross-check or something.
I
It's
mean,
not a issue. Sorry, yeah, sorry, go ahead.
nodes and controllers have different sources of information. So you don't want them to overwrite each other. You want both pieces of information. If the node says it's inaccessible, the controller doesn't matter what the controller says. You're going to do something about it because the controller might not be able to perceive what the node can perceive, and vice versa, right? The controller might know something is wrong and that the node can't notice, and so your health controller wants to get all the information it can, and then if it's going to do something, it should do the thing when it gets the signal.
Okay, yeah, because previously we have some language in the spec talking about if the two are conflicting, we always look at the more serious one and think that's that one.
But that's before we got to a concept of automated remediation. That was still more when we were just trying to aggregate the information from more of a logging perspective, like what how do we present what the situation is.
Mm-hmm.
But I think this is better to say, look, we're trying to automate remediation, and so we need specific triggers that signal that controller to do something with this volume. And we're not making a judgment about which one's worse, or and we're not overwriting, we're not hiding information. I think that's the word you used in your document, Hemant. Hiding information doesn't help anybody here.
Yeah, I mean,
Okay.
yeah, this I did the chat window go. I don't know if anybody commenting on the chat, but yeah. So yeah. So I think we are not the conflict is generally not an issue like and it's much more covered in the like the associated cap is here if anybody wants to have a look. Uh,
Yeah, I've been reading the cap. I think it's
yeah.
worth mentioning that like we should call out somewhere that degraded should not trigger an automated response because degraded could mean lots of different things. Like the only automated response to degraded would be to like raise an alert or call a human's attention. Um, we don't want systems building remediation around degraded unless it's like very generic remediation.
Degraded is mostly informational at this point. Like So we do not want to be like too much prescriptive about this. Like some systems, like I think eventually like might take some action based on some operator or something like
Yeah,
degraded
they may
with
have like a proprietary backdoor to get more information, or yeah,
yeah,
but I think our recommendation is going to be over time we want to add more, and so SP authors are encouraged to detect all the health problems they can and fit them into the buckets we provide. And if we find that we need more buckets, like then having a prototype implementation that uses degraded is a good way to prove that.
yeah. And the next, so status, then the next field here is reason. This is a camel case string again. So like the camel case string that describe the condition is suitable for machine parsing and concise CLI display. This is analogous to like condition API in Kubernetes. So for example, the inaccessible and it will like data loss, and there could be a reasons say that, and maybe I should add more examples here. Like the reason could say that file system corrupted or one or more volumes gone. So this is more adds more context to the error. And this is the last field is the message, like the user-friendly description of the message. So these are the three fields that are there. And because it's an array, we are saying that generally like the plugin must not return multiple volume entry messages for the same volume with same status reason combination. So if you should not return inaccessible and same reason like multiple times. They should be unique basically.
What about degraded though? Because one can imagine multiple forms of degradation, and you want to
They
explain them
have, yeah,
all.
you'll have to report that with different reason. Each
Oh,
degraded will
okay,
have to be,
different reasons. Yes. Okay.
yeah.
Okay.
So the combination has to be unique. The plugin must not run multiple for the same volume with the same the status reason combination. Any questions? So
That's
okay.
fine with me.
Okay. So this basically covers the your controller get volume health, and list volume health is similar, like it just a list of volume health entries, and it has a secret as well, and it just has the pagination APIs. Its response is basically repeated volume health entries as you would expect. So there's nothing like
Yeah.
new here
So,
on
so,
these
so,
two.
so here's where some of my API ergonomics questions come in. One is I have a scaling concern. You have a large number of volumes. Is it going to be faster to call get in a loop or to call list? Like what do we actually plan on doing on the Kubernetes side? How often do we expect to be polling these endpoints? Those kinds of questions. Because
Yeah,
there's a scaling concern, right?
yeah. So in Kubernetes side, if list is available, we'll call list. That's it. Like
Okay,
and we
we
will not
prefer
even
calling
call.
list because
Yeah,
we're going to try to focus on all of them, not not spend more time pulling a few and ignoring the others.
yeah. And the
Okay.
plugin is supposed to report only unhealthy volumes from control list volume. It's not like you just report volume entry with the volume
Uh,
health entries
okay.
with empty type. So it shouldn't be like that long. It is not like list volume RPC where you report all volume. It should only report unhealthy volumes. So I think it has the plugin return health info, the one that knows about, and the plugin should omit volume with no adverse health condition when
Okay.
listing all volume health. So yeah,
Okay, so that really does help because then if you have 10,000 volumes and only 100 of them are unhealthy, list returns 100 elements.
yeah. And in Kubernetes side, we are mitigating this flood of like if there are a couple of things like if too many volumes are being unhealthy or there uh, is by like not too many, but if they're flapping somewhat, then have an inertia. We will talk about that a little bit later. But the in Kubernetes side, we are reporting this in the PVC, and we only report the health volume health status. We have conditions here, and we only report transition time. So we only update PVC object when the health changes. So if the combination of a status and region changes, then we update this. We update the API object in Kubernetes. If it reports the same value, then we don't update it actually. So it does mean that you have the last transition time will be old. So it's like if a volume was unhealthy for 5 hours, the last transition time will be 5 hours old. We had last probe time here, but we chose not to add probe time because that causes a problems. Then you are basically updating it every like 10
And
second, every one
you're
minute or
poking the
something like
API
that.
server really often.
Yeah.
Well, but
And
but
if
but
you,
you mentioned flapping, so there is a concern if
yeah,
if the
I
SP reports good status, bad status, good status, bad status.
Yeah. So for now, like in the this, it's not in the CSI spec, but in Kubernetes side, we are going to have an inertia. Like, okay, it has to stay in that state and not change it. There is a wording here. We we could make this those parameters tunable. It's there in the future enhancement plan, in the enhancement plan, like where we can
I
uh
don't understand the inertia. How do we implement that?
uh so it has to be like because we are not storing an API object, when was the last transition time reported? It has to be done by storing the timestamp in the like whichever like external health monitor or kubelet, which it says, okay, I reported this change and I reported unhealthy. Now it turns to healthy. I will not change this time. I will not change this unhealthy until like 5 or 6 polling still reports it as healthy.
That
You know
doesn't
what
make
I'm
any
saying?
sense to me. Like if the SP says it's healthy again,
Mhm.
why wouldn't we trust it to say, oh, it must be healthy again?
We would, I think we'll have to define inertia because it could be flapping. And if unhealthy, okay, SP said it's healthy again, and then it changes again back to unhealthy every poll, every like 1 minute, let's say. There's in Kubernetes, there's a policy how often it is polled, and we will use for the now for the timing we'll use the same field that we use in Kubernetes. So like the frequency with which we get node get volume stats basically. So if if every polling it changes, then do we want to change it?
I say yes. I mean, the case you talk about is bad, but like that's a bug in the SP, right? The SP
Hmm.
should be the thing that is suppressing flapping, not Kubernetes. Because if the SP says it's healthy again, you don't want a controller going and acting as if it's unhealthy.
Okay.
Like we shouldn't be second guessing what the SP is telling us. The SP should just not have bugs.
Okay.
I
I
mean, if you wanted to implement some sort of a flapping prevention, I think what you would want to do is count transitions over time and throttle how often you pulled if it was transitioning too often, but not have any hard cutoffs on like, if it was only unhealthy for 2 minutes, then got healthy again, we ignore that because maybe it really was only unhealthy for 2 minutes and now it's going to stay healthy from now on. Um, and you want
but
to
if
update
it
it immediately.
okay, I
I mean, a
think
lot of
that's
health problems really are short-lived, right? Like
it could be
the
like
switch reboots, you lose a route. As soon as the switch rebuilds its routing table, the route comes back and everything is unhealthy for 90 seconds, but then everything's healthy again. And that's just the ground state of truth. Um, so
I
yeah, I
think
would.
I yeah. Okay. All right. So that's a discussion that and as for like how often this will be polled, so like it's not right now in the CSS spec, but it is in the Kubernetes spec that we want to configure it via CSI driver object, like a like a health check policy. So, but that we are not implementing in the current alpha. We want to get it out, and then we will approach this by
But
doing
there's no
okay.
reason an SP can't implement that internally,
Yeah,
right? So
yeah.
why wouldn't we just say like that's how it should be done? Like this is not our problem.
Wait, like it's Kubernetes that polls those RPC, right? So the
Oh,
if
you're
SP,
saying that the thing that's tunable is the polling interval?
yeah.
Oh yeah. Okay.
You asked that, like how often it will be checked. So we
Okay,
are
okay,
thinking like for now we will default to a value that we use for other things like the limit and all we poll. Same thing. There's a field that is tunable in Kubernetes in the
okay.
kubelet. So we'll use that field, but in future, like that's the plan.
Yeah. I think that makes sense because there'll be a lot of clusters that only have a few hundred volumes and it won't be a big deal to pull them frequently. But if somebody wants to build an enormous cluster with 100,000 volumes, they can turn the pulling frequency down so they don't knock themselves over.
Yeah. Okay, so I think that was in the this get volume and the one question that I obviously had was like whether to deprecate this volume condition fields or remove them. I for my first iteration removed it, but then I noticed that the moment I tried to build CSI, the host path driver, I tried to pull this in, and the compilation failed because it was trying to set those fields and it was failing.
Wait, what? You mean removing health statuses?
The volume conditions from the old the list volume
Oh,
and
oh,
get.
oh, yeah. The deprecation of a gRPC feature, you have to sort of keep the old slots reserved forever
I I I
for backwards
did do
compatibility.
that, yeah,
That
but
wasn't enough?
that was not enough. The because the driver was setting those fields like and it would fail actually. Like if the driver had this if it implemented this volume condition RPCs.
Saad, have we ever formally deprecated and removed something from CSI and had to go through this issue?
I think we've deprecated things that were alpha, but I don't think we've deprecated anything beyond that.
Okay, well this
I
this was alpha, so I think it's fair to remove something that was alpha, and then any CSI driver that was using that feature will stop compiling when they update their CSI. But that's what you get when you use an alpha feature,
Yeah, let me
right?
go
You
see
have
if I
to.
can find an example. I'll be back. Hang on. Go ahead.
Okay. Yeah, so Neil was saying, yeah, that removing is correct because the initial version I did had added this reserved field for all the fields that I was removing. I added
Yeah,
this
yeah,
reserved.
that is required, but I don't think we have to prevent breaking compiled code if the compiled code was actively using an
So
alpha
that's the
feature.
thing. Even if you actually, let me back it up. So even if the ability, the driver actually the capability is compile time like runtime enabled, the CSI driver, the host path driver supports that enable disable volume condition. I think it still fails compile time errors with compile time. So you disable it, but basically at compile time it still fails.
No, I'm okay with that. Are you saying someone who never implemented the alpha feature, their
Oh
code
no
won't
no no
compile?
no no no, they will
Okay.
compile, I think. Yeah.
Okay, well, but that's fine. So you used an alpha feature and we're removing it. So of course it's not going to compile. You have to change your code to get it to compile. You have to remove because it's
Okay.
deprecated. So you got to remove the alpha code. I,
So we need
I,
to
I,
update our CSR host pass driver first before, otherwise you wouldn't be able to pass tests, right?
Yeah,
Among,
you'll have to
yes,
update. Yeah. Yeah.
yes. And I think that's reasonable if our stance is we're removing this. So why would we want that code still around?
Okay. So the next thing I want to talk is the node get volume health has similar mechanism. Actually, nothing. It just reports same volume. Actually, there's a one change here. Sorry. So the node get volume health, I don't know, maybe I need to fix this, but controller get volume health reported an array, but node health volume I have added here only one. Maybe I need to fix that.
Yeah, that should be an array.
Hmm.
And remind us why there's no list, node list volume health.
Uh,
Because the performance optimization of only returning the unhealthy ones is huge. And here you're saying we can't do that. You have to enumerate all of them, even the ones that are healthy, and get their health, which is going to cause scaling problems. If a node has 1,000 volumes on it, you got to call 1,000 node get volume
generally
healths,
like,
right?
yeah, generally like the the idea was like number of volumes you can publish is limited by like the operating system. Like you can only attach so many volumes on different storage
Usually,
group.
but
Yeah.
that's not true in all cases. And even when it is, the limit can still be in the hundreds, high hundreds, maybe 1,000.
So that's not okay. I mean, I agree, but at this point it's not implementation blocker for alpha if we have to like it's an optimization, right? So we can come back and say, oh, I my driver needs this, so I would uh, I would
Well,
prefer to
but
have
I
a
wanted to
node
think
get
about
volume.
it conceptually. So like controllers are supposed to know about all the volumes, which is why a list is a reasonable thing for a controller to implement. Is
Yeah.
it reasonable for a node plugin to know about all the volumes, or because they tend to be stateless, is it not even reasonable? Um,
Generally,
or
like,
or is there a better
yeah.
way? Because I just the performance optimization of a list sounds so valuable that we should think about if there's a way to get it on the node too.
I'm not opposed to it actually, but let me just add here like this thing. Sorry. So uh, should we have a list? Uh, uh, I mean,
What,
it's
d-
yeah.
does anyone who has an SP implementation think that they could even implement a list on the node? Like, do nodes have enough state where they could efficiently iterate over all of the do they even know like the list of things that are attached to themselves, or are they relying on kubelet to keep track? I'm actually thinking about that myself, and the node might not know because the nodes are pretty dumb.
Most CSI drivers actually know volume that are published. They keep some sort of state to prevent like the concurrent operation and all like because that is part of CSI spec actually. You should not have like two node published going at the same time. So they need to report aborted or something for the second one, if I remember. So for those reasons, I think the drivers do keep some state of
For
operation.
individual, I think if there's multiple calls for the same volume, yeah,
Oh,
I think
yeah.
that would apply, but you're allowed to publish two different volumes in parallel with each other,
Mhm.
and I don't think that the driver needs to anywhere have a list of all the volumes that are published in order to properly work. Which is why we have all these things, staging paths and published paths that the CO is required to pass in, because the driver is supposed to be not remembering that kind of thing and relying on the CO supplying it the state information. Um, so
Okay, but
maybe it's not even practical to implement a list, and this is just going to inevitably be slow. But we should think about the scaling implications of that.
I will add this in the enhancement actually, like in this one. So there is a bunch of future enhancement that I want to do follow up, and I think I'll add it. Like some are more realistic and practical, and I want to get to it. So yeah, I think I'm not opposed to it, but yeah, I okay. So can I Ben? I do not disagree, but like
Yeah,
can I
yeah, but
bring this?
we can move
Yeah.
on. We can move on.
Yeah. Okay. So the next one that I want to hear in node get volume is like unlike node volume get stat that requires that the volume is stage or published, this actually this can be called on by the driver by sorry by the CO that has recently attempted to stage or publish. That is one catch that I have we have like I have added here. The idea is like if node publish or node stage fails. Usually, like the health information that is available for the volume is limited. This allows the CO to like get more detailed information about why, if it at all it failed. So
So wait,
so this
you're saying the CO attempted to publish or stage a volume. It didn't
yeah
succeed.
yeah
And then the CO comes back and asks for the health information. So if you have an SP that doesn't have any state at all, is it acceptable to just say, I don't know, like
yeah
just
yeah yeah.
return
It
that
it can just
it's
return I
fine.
don't know anything. Yeah
But you're saying if you do know, then the CO might ask you and you can pass back more information, which is helpful
yeah
to the CO.
yeah
Yeah, we just need to be very
exactly.
careful about not putting a stealth requirement on SPs to store any additional state if they don't want to. That's the main concern.
Okay.
But if they have the state, exposing it doesn't seem bad. I can't imagine why it would be bad. Um, I mean,
Yeah, so this,
it, I think you okay. So let's say you call publish, it fails, um, and then you call unpublish, and that succeeds, and then you call get volume stats. Like at that point, you're not expected to return anything, right? Because you've already said I want to unpublish this, which means the SP is welcome to forget all the state,
yeah, yeah,
even if
yeah,
it had some.
yeah.
Unpublished wipes it
So
out. So okay.
yeah, in Kubernetes sense, like we will only call node get volume health for volumes that have made into the desired state, have not made into actual state, but made into desired state, and like we'll see, okay, what happened. So we will, if the volume the pod was deleted in case controller node unpublished was called and that succeeded, then the volume is removed from the desired state. So there's no need to call node get volume health. So
Okay.
this is one pain point that this RPC call addresses. Okay.
So can you just elaborate on like real world where this comes in? Because
Yeah.
I'm
So for example, like a volume failed to publish because of like like file system corruption that happens like I don't know for some reason like we see this often and in that case this will allow the storage provider SP to return more details about why what happened with the volume why it failed. So
okay, but
that's
would that be reacted to in so the case you mentioned, file system corruption, that would be a data loss, right?
yeah,
So
exactly. So
so
the
would the data loss controller then find out, oh, this node has data loss on this volume and then
yeah,
do its normal thing?
yeah. So then the plug the PV the it will be reported as data loss. Actually, it's the data loss in Kubernetes side, the health condition from the node is not reported on the PVC. It is reported in the pod. So that's but so the operator that works on it will see the data loss and will have to do some action based on it.
But the data loss would be on a pod, not on a PVC. So if there was a controller that was like dealing with stateful sets and it was going to try to reconstruct the corrupted PVC, it would never see the PVC that was corrupted. It would just see the pod was had a data
But
loss.
it will have the volume name and everything in the pod. So it's a field. It will have like, okay, this
Okay.
volume is corrupted or
So
it has
so
data
you're saying that
loss.
that controller that reacts to data loss volumes is going to have to monitor both PVCs and pods,
Yeah.
and it's going to have to
So
go look at the pod details.
yeah. And the
Okay.
reason, again, when we discuss this, like the reason we are not reporting the volume health from node in PVC is because of the scaling concerns. For many read write many volumes, the same PVC could be published. Like the scaling concern was the primary, and then the like the nature of like then the scaling concern was one, like the same volume could be published to thousands of node, and second was like the staleness, like the pod is the volume is
Well,
removed from the node. So
I'm
yeah.
concerned with the different scalability issue, which is the number of pods tends to dramatically outweigh the number of PVCs. So if the controller has to have an informer for pods, that weighs a lot more than an informer for PVCs, just in terms of how much data it has to store and how much traffic it has to deal with.
S-
So that
Yeah,
that
but
that
this
informer will be a
is
lot heavier.
this is reported in kubelet, right? So kubelet is not keeping informer for the all pod. It's only kubelet is updating this for pods which are unhealthy on that node. So
Yeah,
l-
yeah, but the controller that deals with data loss, that's looking at your whole cluster. And
uh
if this information is meant to make its way back to that controller so that it can do the thing that it does when it sees data loss volumes, then that controller has to be watching the pods too to find out that there's a problem that it needs to react to. That's the
yeah.
concern.
hmm I
Because
would
kubelet can't do anything, and it just does what it normally does for dead pods. But for data loss to be useful information, then the controller that deals with data loss has to be watching all the pods in addition to all the PVCs.
Mhm. I mean a
I
lot
mean,
of
it's not
yeah.
the end of the world. It's a scaling concern.
Okay. Okay, noted. And so yeah, it has all this. So it has the volume not exist if volume ID is not found. Then node get storage health is the another RPC call that the storage system health from the node plugin. And it's as you expect, it has a secret and it has the so it this is where it gets slightly tricky. It introduces new fields here in the it doesn't reuses the volume health enum actually. It has a repeated an array of storage health conditions backend called backend health, and that has status which is our unreachable degraded right now, and actually it doesn't have a data loss for the whole backend. And then it has message, and it has the volume capability, the which capability of volumes are affected by this the storage health. So this is about the whole backend health on a node actually. So
Okay, so you said it doesn't have data loss. Is that because it's using a whole different enum?
yeah, it's using a whole different enum, and at this point I added unreachable. So do you think I did not think a use case where like a whole node will report a data loss
I,
like
I
for
agree, like that is unlikely, but like the economy of just having one enum, because as we add, are we going to want to add new things to both enums or just have one enum that you can add things to? And we can just say, look, data loss is a thing that doesn't apply to nodes. It only applies to
yeah,
volumes.
we could do that, but I
Like
ended up
unless we
different.
think these two enums are not going to tend to have the same elements. I,
That's why yeah, for like the future like enhancement and propose perspective, that's why I chose to keep it separate. And in case like sorry, uh
I
somebody
just
else.
I have a strong bias towards like not just having informational reporting, but actually returning things that can be acted on. And if we're going to implement controllers on the Kubernetes side that like deal with inaccessible volumes and deal with data loss volumes or some future thing, we were going to want that to be done consistently. And having an enum that is the same across both is going to make it a lot easier to say, okay, inaccessible means inaccessible. And the controller that deals with inaccessible knows what to do with those. And so we're going to report them in a consistent way. Um, Otherwise, you'll have inaccessible controller, inaccessible node, or some future problem, and you'll have two different flavors of it, and we'll have to decide. Well, does the controller want to deal with both the controller and the node flavor of this? And I don't know. I don't see anything
But
good coming out of
at the
that.
same time, but like for example, say we added the storage like I don't know, like one of the thing is like we added explicit field here for something like uh multipath unavailable, one or multipath unavailable. That will make sense for
But
from the node, but it may not be make sense
but but
from
but,
the
but if
controller
we
side.
have if we had one enum, like we can just say for each enum, like this is only valid on the node. This is only valid on the controller. This is valid for both. We can just say that for each
Mm,
one. Um, and then you can even have conformance tests that enforce that. I think it's better to have one enum, and then if we really think certain enum values shouldn't be used across both, just say that. That'll simplify the handling on the other side because it'll be unambiguous what each one means. That's my opinion. I don't know, does anyone else
okay.
have a different opinion? Just I don't know how much more you have to go. In the interest of time, I
That's
wanted to
it.
I wanted to
Yeah,
bring it.
that's
Okay, the secrets. We always have problems with secrets in CSI, and this is another case where like it's going to be very unclear like which secret do you pass into the node storage health request, right? Because typically secrets are associated with a volume. Um,
yeah.
and so like whenever you have a list, it's unclear like what secret do you pass into a list. And say this is sort of like it's not a list, but it's one where you don't have a volume. So I'm not sure where we're going to get the secrets that need to be passed into these APIs. I'm not opposed to having them on the CSI side, but it creates a design problem on the CO side. Like where are the secrets going to come from?
I mean, we
Is it,
can. Yeah, like it's gonna be interesting because some drivers may not want to have secret on the node side for security
Yeah, yeah,
reasons.
I'd say the most SPs just ignore the secrets and no one cares. So the secrets are just an empty map. But for the ones that
Yeah,
care, we tend to just gloss over those and not deal with them, and it's led to a mess in terms of how the CO is implemented because we don't think about it until it's too late. So I'm trying to take the opportunity to think about it now and say we should have an opinion about where the secrets are coming from, and we should document that, um, and just make sure that we don't surprise ourselves on the CO side and be like, oh, we don't actually have a secret to pass in here. And then some SP shows up and says, I actually need you to pass in a secret, and you didn't implement a way to do it. Um, and then
yeah.
we have a different
I
problem.
I I hear you. I think we have explicit field secrets for various RPCs in PV object, and it's not clear that like okay, where will we store it? So yeah, that gap is there actually in the
On the CO side, like it's not a CSI
user
problem, it's a Kubernetes problem.
interface. Yeah. Okay. Let me think about that, and I'll update this. Okay. Uh, and yeah, in interest of time, the CSI snapshot topology. Anybody wants to talk? Is there anything else on this you want to talk about more?
Hey, yeah, I just had one quick thing. I think to click on the different cycles of confirmation that we do, right? So in the cap, we defined two, and beyond health, volume health oscillating. The reason we did that too is to address the paging gap. So I think for list volume, CSI spec also tolerates this,
Yeah.
where it with pagination, right, you might see duplicate entries, or you might even miss an entry altogether. So that's for plugins, by the way, that support both RPCs, right, list and get, we don't have like the two cycles to confirm. If it's absent in list and we want to clear the error, we do make a get call to get that confirmation. And then for plugins that don't support the get RPC, the reason we have two is because that's sort of how we address the problem where it might not show up in list, but the volume is still actually unhealthy. So it's more
Wait,
aligned.
how did you're saying we list twice in that case?
Yes, yeah,
Because I don't understand how that fixes the problem. Like if the reason you didn't see it in the list was because pagination problems, that can happen twice.
yep,
No,
absolutely.
no,
So
no. But then we use get call, I think, that to solve that inconsistency.
yeah, so we call for plugins that support both.
Okay.
If you support list but not get, then we have two cycles as confirmation. And Ben is right? Like you might run into the problem twice in a row. Now it's very,
Well, well,
very,
in CSI, like it is legal to implement list without get because we actually didn't have get until after list. For this
yeah.
feature, can't we just say you must have get if you have list? Like you can't implement one not the other.
Mm.
That would solve the problem, right? Like you have both or you have none.
Mm,
Yeah, that's a good idea. I think because yeah, I mean that's basically when we have the two cycles, right? It's just because to address this paging gap that could happen. So I'm not opposed to making get required
yeah.
here for confirmation to clear it. I think that's a good idea. Mhm.
Well, and how is it that we ended up with a list that can have pagination problems? Because I thought this was a solved problem in the field. Aren't there ways where you can ensure you don't have pagination problems?
Yeah, I think this is the problem that the next token is resolving.
We have starting token and
Yeah, I think we are expecting an consistent listing across page.
well, yeah, I can see individual SPs implementing this wrong so that you can miss things. But if an SP wants to implement this correctly, is it possible? That's the crucial question. Um, if you do starting token, next token, next token, next token, uh, can an SP return tokens in such a way that like even in the face of a list that changes multiple times during the iteration, can you ensure you get a complete view of the list? It's a it's a thorny problem, but it has been solved, and we should we should have a CSI RPC that makes it possible at least to do it correctly, even if we don't mandate that you do it correctly.
Okay.
I don't know. I'll have to think. We can think about that offline.
Yeah,
But
yeah.
listing is hard. Uh, like for file
Okay, does
systems have to
anyone
have this
wants to?
problem where you can delete and add files in the middle of an LS call and it has to do something sane.
Okay.
We got 7 minutes left. Do we want to spend time on the second topic or save it? CSI
I
snapshot
would like to get
topology.
started on it.
Okay, go for it.
Yeah. So, I can't share my screen, unfortunately, but
Hang on, I
being
can get
sent.
you up.
Okay, we have to make you a co-host, then you will be
Yeah.
able to.
All right, go
Got
for it, Raphael.
Great. Thank you. I believe this is the right tab. All right. So yeah, basically, here we're just introducing snapshot topology to the CSI spec. For a little bit of background, the reason how we ended up introducing this was because I initially had proposed implementing snapshot cloning capabilities, but we talked about not doing that without having snapshot topology implemented first. So that's basically how we ended up here. So for this change, we're making 3 changes to the spec. So one of them is we're adding the plugin capability of snapshot accessibility complaints, right, constraints. We're adding accessibility requirements to create snapshot request, accessible topology to the snapshot, and then one new error message to indicate that even if the accessibility requirements field is valid, the snapshot could not be created for some reason on the SP side, and they need to fix that before the next call happens.
So at a high level, are we copy pasting what volumes do? Is that the approach here?
Yes, basically.
Okay.
So the first field you added in the create snapshot, where was it? Sorry. Oh, it has a topology requirement. The first one. Oh, that was the system.
This was for the plugin capability.
Okay, cool. And then create snapshot has a field for accessibility requirement.
Yes. That'd be this one right here.
I added one comment about the create volume request. I thought you have that in the cap. Or, if you have topology requirements in the create volume request, and then if the data source is a snapshot, I thought you have some language in the cap because then they have to be in sync, right? It can be.
Well, I mean, we already have accessibility requirements in create volume from snapshot because it uses the same RPC.
I'm just saying there was some should there be some language there, right? So if this is out of sync with the snapshots topology, what should we do? I thought we have something in the cap, Raphael?
Yeah. So you're saying so like if you're saying if it's out of sync with the snapshot topology, so like if
Right. Yeah, we should have something there. I think we should add something in the create volume request there.
I mean, the ultimate truth comes from the SP, right? SP either succeeds or it doesn't. I think
Right.
what we would want to say is if you create a snapshot with accessibility requirements to be in some topology and it succeeds, and then later you try to create a volume in that same topology, it better not fail because of topology related reasons, right? Today it is allowed to fail for topology related reasons because we don't know what it is. But if you say it's going to work, then it should work.
They should be the same, right? I thought we have something in the cap, isn't it? Like
wait, let me look because I'm not sure what you're referring to exactly. So I know right now. So if that was to be the case, like if for example somebody tried, you guys can still see my screen, right?
Yeah.
Okay. So if somebody tried to do something like that, where they would try to create a volume and then, for whatever reason, they try to do it somewhere that the snapshot is not accessible and they have that snapshot as a source. So depending on the type of, sorry, give me 1 second.
I had a different question, by the way.
Yes.
Why does create snapshot needs a accessibility requirement? Can that be not be determined from the volume that we are trying to snapshot?
That was the
No.
assumption
Because
that we made years ago when we
Like,
decided not to implement topology for
no.
snapshots.
The source, the response deserves maybe a accessibility requirement, but
hey, I think
the
we
s-
only have 2 minutes. We probably need to schedule another
Yeah,
follow-up.
yeah, yeah,
yeah.
yeah. I think we're gonna have to
Can we
follow up,
schedule
but
that?
I wanted to have
Yeah,
time to introduce
yeah,
this topic so people could
yeah,
get
yeah.
thinking about it.
Because I
Um,
need to drop soon. I was just
uh,
wondering, can we have
so,
a
so
set a meeting tomorrow? Does that work? Like tomorrow, the same time work for
I
everybody?
have a conflict
Oh,
tomorrow.
yeah, conflict.
Friday could work, but that might be a
But that's
holiday
that's a
mostly. Yeah,
holiday
that's
for
a holiday.
everybody, right? Holiday.
Yeah,
Hard
Friday
to
is a
tell.
Well,
holiday
our
probably.
next regular CSI meeting is only 2 weeks away.
It's 2 weeks.
Maybe
Yeah. Is that?
we aim for that.
Oh, are
Okay.
we not having the one today? The
This
one at
is
1
it.
p.m.?
This is the regular.
No, the CSI some implementation
There
meeting
is
actually he's
information there.
talking about.
Yeah,
I cannot join that one because I
that, that,
have
that that's a
Oh,
different
that's a
okay.
different
different
audience.
meeting. Yeah.
Got it, got it,
Um,
got it. Okay.
I just wanted to call out. Do we address backwards compatibility with this design because we have a whole bunch of existing snapshots that don't have any topology information?
Yeah.
Do we know how we're going to handle that?
Yeah, so basically, what's going to happen there is that if we see that the snapshot that is your source has no topology, then everything is going to behave exactly as it behaves today. Like we won't try to look for any intersection or anything like that. So that was not what the purpose of not breaking the existing
Okay. Okay. So we've
flows.
thought that through. All right.
Yes, yes.
Good. Um, yeah, I think we need to follow up on this because we're out of time now. But
Yeah.
seems like a good start.
Uh,
All right, folks.
okay.
Okay. So let's
Thank
try
you.
to schedule some
Uh,
another time. Yeah.
Yeah, sounds good.
So
Take it
Right.
offline.
Okay,
let's
great.
Thank you.
thank you guys.
All right, thanks,
Thank
everyone.
you.
Take care.
Thank you.